Okay, hey everyone. Welcome to our first lecture. I'm going to be talking over this PowerPoint, and you can take notes as you see fit. It's really important that you follow the PowerPoint, as a lot of this information is going to help you, one, with the homework, and two, with really just like test and quiz questions, because you can use your notebook on the tests and quizzes. So hopefully that is helpful to you, and you can listen to this as many times as you need to. Okay, the first thing I want to point out is the title of the lesson, How Do Scientists Learn and Think? It also says Unit 0. So the whole point of Unit 0 is to give you a better understanding of the the background to biology, the background to science, and so the setting up the tone for how biology is done is very important. So that's why we talk about how do scientists learn and think, because there's a very specific set of standards that we have for that. You'll also notice that it says day 4, 5, and 6. You can ignore this. It just means, like, when I had block schedule last year, obviously we're distance learning, so this is not applicable. But I label all of my lessons unit whatever and then day blank, blank, and blank. So if you are interested in being organized, this is a great way to stay organized and keep everything in order, and also to make sure you haven't missed anything, because it will be um, it, it will go in number order. Anyways, so the agenda is going to be a little bit different, obviously, because we're not in class. We'll do some of these activities in class together, but this is really just for you to get prepared. So we're going to talk about observations and inferences, and that's going to take up a little bit of time. This homework will be done in class, so don't worry about it. You can start thinking about it after we go over that section, but it's not due. Obviously, we're not having a break, and then we'll go over the scientific method. What is it, and how do we use it to solve problems? This scientific method portion should totally be a review for you, especially if you took middle school science. And hello, you totally had to take middle school science in order to be here. So scientific method should be a review. If it is not a review for you and it's something new, you really need to spend some time going over this part of the lesson. So normally I will have um, a do now for you. You don't need to worry about the do now here, just because, again, we're not together. I do want you to, however, to write down the objectives. Okay, the objectives, all that means is the things that I want you to be able to do once this lesson is over. So after you've watched this video and also done the work in class, you should be able to do these things. So when you write it down, you should be saying, I will be able to distinguish between observations and inferences. To distinguish means to tell the difference. Okay? The second goal for you is that you will be able to know the steps of the scientific method to solve a problem. So if I present you with a problem, for instance, why are the leaves on a tree green? You would be able to use the steps of the scientific method to figure out a reason for the leaves on the tree being green. The third one is that you will be able to identify independent and dependent variables, constants, control groups, and experimental groups. This last one is a part of the scientific method. So basically, this is a vocabulary goal. So I would like you to know, what is an independent variable, what is a dependent variable, what's a constant, a control group, and an experimental group. So observations and inferences. So if I'm taking notes, I want to title this just as it's listed here. And then if you need to pause, you can, and then move on to the next slide. So underneath observations and inferences, I have A, which is observations. Now, anytime I have, oh my goodness. Anytime I have a pencil in the upper corner or anywhere on the page, it's probably a good idea to write this down. Again, you don't necessarily have to write this all out if you're using your OneNote notebook because I'll have this slide in there already. But yeah, so you might want to take notes on the side or whatever the case may be. So an observation, what is an observation? It is the gathering of information by using our 5 senses. That's using your sight, your smell, your hearing, your touch, and your taste. Obviously, this is hidden by this bar down here, but yeah. There are 2 types of observations. There's qualitative observations and quantitative observations. You're going to want to leave some room to write underneath both areas. So, qualitative observations describe what we observe. Okay? Qualitative means that we are describing a quality. An example of this is the flower has white petals. The flower has white petals. This is opposed to a quantitative measure. This is how many, a quantity, it's a number. Okay, we're giving a statistic. We are measuring what we're observing. So an example of this is the flower has 7 petals. Notice how the last example I gave, the qualitative example, said that the flower has white petals. Okay, but if I look at the next slide, it's asking me, okay, the flower might have white petals, but how many white petals are there? Well, quantitatively, there are 7 petals. So obviously you can't practice with your partner, but this might be a question that comes up in class that we'll go over. So you should try it on your own right now. So this practice question says, the road is long. The road is 5 kilometers long. The road is long is just describing the road. Giving an actual measure for how long the road is given here as 5 kilometers. So which statement is qualitative and which statement is quantitative? Okay, I'm going to see real quick. So the road is long is a qualitative description because it's describing a quality of the road. It's just long. A quantitative measurement is something that measures the road. So the actual distance of that long road is 5 kilometers long. That would be a quantitative, a numerical measuring statement about the road. So I really like the show Friends. And if you've ever watched it, there is a character named Phoebe, and she has this original song that she sang, which is pretty funny. Love that show. But it's a good example of qualitative versus quantitative. So she is going to sing this song, and we're going to watch it real quick. Let's see.
I'm going to start off with a little song called Smelly Cat. For those of you who are wondering, this is my real voice. Smelly cat, what are they feeding you? Everybody! Smelly cat, it's not your fault. Monica!
They won't take you to the vet.
Chandler!
Obviously not their favorite pet.
Joey!
May not be a bed of roses.
Rachel!
You're no friend to those with noses.
Ross, those are the only lines we have, sorry. Okay. Back to the chorus, everybody. Smelly cat, what are they feeding you? Smelly cat, it's not your fault.
A smelly cat! What are they feeding you?
Yeah.
A smelly cat! It's not your fault.
Oops. Okay. Good. So, again, Phoebe is saying in this video that the cat is smelly. That is a qualitative statement, right? But it's just hard to know how smelly the cat is. So to make this a scientific statement that gives a quantitative statement about the cat, we would need to say that we would need to rate the smelliness of the cat. So we could rate it on a scale of 1 to 5. We could make it 1 to 10. That's really up to you as the scientist. But again, anything that we talk about and make statements about qualitatively, we can also make quantitative statements about just by giving it a simple scale for rating or some other method. Again, this would allow you to compare how smelly the cat is to another cat, right? So let's say Phoebe's cat is super smelly. We rate it a 5 out of 5 on the smelliness scale. Okay, and we come across another cat on the street, and that one's pretty smelly as well. Well, how do I know which one's smellier? Again, I'm going to have a set of criteria, right? And then I'm going to rate it again on the same scale. So maybe that cat is a 4 out of 5 on the smelliness scale. Well, okay, my cat then would be, or Phoebe's cat would be smellier than the cat on the street. I know that because I use the smelliness scale, as opposed to just saying, well, both cats are smelly, so they must be equal smelliness. I know this is kind of a funny example, but yeah, that's how we do science. You know, it doesn't have to be super serious all the time. It can be something as funny as this. So now that we've kind of figured out what an observation is, right? We're just taking in information when we're making an observation. We're gathering information. But we need an explanation for what we see. Okay, that's what science is all about. So we have this idea or this theme called inferences. Inferences are explanations for your observations. Okay, they are based on your past experiences and prior knowledge. So meaning prior knowledge means when you come into a space already having knowledge about that topic or having an experience that gives you a little bit more insight into what's going on. Inferences can change when new observations are made. Okay, inferences help explain observations. So this bottom one, inferences are often changed when new observations are made, is a really important life lesson, really, because your opinions and what you believe to be true can change, and it will change as you grow up. Obviously, you know, this is not totally related to the lesson, but again, as you observe and spend more time doing life, your reasoning for things that you see change all the time. And so, you know, something that happens often is people get so stuck in their ways and they say, well, it's always been this way, so it has to be that way. But I encourage you to put that to the side, and I encourage you to kind of have an open mind and open view when it comes to science, because lots of things that we'll talk about in this class will say, well, this, and that only happens a certain way. And then I'll show you videos of it happening a different way. And that's really just to get you new information, to make new observations, so that you can come up with new explanations for why things happen within our world. So we're going to do this in class, but I just kind of wanted to go over this as an example. I think you should make this chart in your notes and try and fill this out now so that you have examples for when I call on people in class. So practice, observations, okay, and then possible inferences. So we have information that I've gathered by my 5 senses, and then possible reasons for why those things are happening or why I'm seeing those things happen. So let's say I walk out of my house in the morning and the grass on the lawn is wet, okay? There could be several reasons for this. Okay, so the inferences that I came up with, I said it could have rained. Notice how I said possible. I'm not going to say this is the only reason that the lawn could be wet. Okay, that would be ignorant of me, because unless I visibly watched the grass the entire night, I cannot really say that it is only because it had rained. It's possible it had rained, but if it hadn't rained, then another possible inference is that the sprinkler was on in the morning. And that's why when I walk out, the grass on the lawn is wet. A third reason that the grass could be wet is that there was dew on the grass from the morning. So if you don't know what dew is basically moisture from the air that kind of landed on the grass and formed water droplets. And so we call that dew. Okay, so that's another reason why the grass could be wet. It didn't have to rain for dew to be on the grass in the morning. One final kind of funny reason that the grass could be wet is because maybe the dog urinated or peed on the grass. That's also possible, right? It doesn't just have to be a dog. It could be a cat. It could be a raccoon. It could be anything that is in your area. Oops. What's happening here? There we go. So again, I would like you to fill out some possible inferences for why the school fire alarm could have gone off, and or a student is sitting in the main office. What are some possible reasons why these two instances could be happening? So fill that out there. Just come up with 3 or 4 examples. That way that you have something to share in class. So we have a worksheet that is called Observations and Inferences. We're going to have this in class when you come to class. It looks like this. I might make it into a Google form to make it easier for you to write on, but it will have the same questions. So this top area is referencing the PowerPoint, the portion of the PowerPoint that we just went over. So it says, scientists need to be able to separate their observations from their inferences, right? What we see versus why it happened. So observations are facts that you can discover using your 5 senses. They can be qualitative, describing a quality, or they can be quantitative, describing a measurement. Inferences are opinions based on observations and past experience. So again, inferences are reasons why something might be happening. So when we come into class, when we do this worksheet in class, you're going to make 3 qualitative observations about the picture to the right. So that's this dinosaur head here. There's lots of things to say about this dinosaur head. You only have to say 3. And again, qualitative means qualities. We're just describing, okay? Then it says for number 2, make a quantitative observation about the object. Again, if you're watching this video, you kind of have a better insight. I would talk about maybe how many teeth there are or how many holes I can identify on the dinosaur head. Okay, quantitative is talking about quantity. Okay. Number 3, what can you infer about the object based on your observations? So I gave you a little sentence starter here. You could say something to the effect of, based on my observations, I infer that blank. Okay, that's how you would write out your sentence. And again, you could say something to the effect of, because the dinosaur has such dagger sharp teeth, or based on the fact that the dinosaur has such sharp teeth, I infer that the dinosaur used to eat meat. It's a carnivore, okay? Because it needed big teeth in order to rip apart the flesh of an animal, okay? That's just an example. Number 4, write a few sentences to explain why scientists need to be careful about distinguishing between observations and inferences. What is bad about getting it wrong? This is something that we'll talk about in class, but again, separating your opinion from what you're seeing is a huge lesson in science. You have to be able to separate your personal feelings from just hardcore facts or observations that you're seeing within the world, because sometimes it's not going to make sense what we're seeing as compared to what we've been taught in the past. And so again, I say this over and over again, wanting you guys to be open to just hearing new ideas and new inferences or new possibilities for why things happen on Earth and in space. Okay. So going back to our PowerPoint, we're now going to talk about the scientific method. So now you're going to label your notes. Number 2, scientific method. I will post pictures of my handwritten notebook as an example in case you're not using the online notebook, so that you can see how I kind of take notes from this PowerPoint. So yeah, but this is number 2, the second topic for today. So what are the steps of the scientific method? Again, this should be a review for you, but if it's not, I'm going to go into depth in each one. So number 1, ask a question based on observations. So let's say I go outside, I look at the trees, I say, why are the leaves on the tree green? That's my question. It's based on me seeing, using my sense of sight, to make an observation about the color of the leaves on the tree. Then I'm going to form a hypothesis. This is a possible explanation. This is where you come up with a bunch of different inferences for why the leaves on the tree could be green. I'm going to come up with some examples right now. So for example, the leaves on the tree could be green because it's not fall, right? During fall, they might be orange or red. Right now, it's not fall, so I'm making an inference that it is not fall. It is not fall, therefore, the leaves are still green. I could also say the leaves are green because the tree is well hydrated. I could also say the leaves are green because the leaves have chlorophyll in them. Just a bunch of different possible explanations for why the leaves could be green. I'm then going to create an experiment to figure out if I'm correct. Okay, so let's say I pick one of those hypotheses to create an experiment about. I'm going to create the experiment, I'm going to run the experiment, and I'm going to collect data during that time. Okay, so let's say I chose the hypothesis, the leaves are green on the tree because we're in summer and not fall. Okay, so what I would do is I would create an experiment where I collect leaves from a tree during summer months, and then I collect leaves from the trees when it's fall months, and then I collect leaves from the tree when it's winter months, and I compare the colors of all of those leaves. Okay, that's me performing an experiment and collecting data, right? Maybe I take pictures of all the leaves so that they don't die off, and then I can get their true colors. The fourth step of the scientific method then would to be analyzing the results. So if I took pictures of all those leaves and I labeled them winter, fall, and summer, then I could look at all three colors side by side and determine, this is step 5, a conclusion. Okay, I can determine whether or not the leaves on the tree are green due to the season. Okay, and then I would communicate my findings, right? Let's say, I wanted to share that information with the class. Then I would go and make a presentation to show you guys all that I did, all the work that led up to me forming my conclusion. And then, I would present it to you all. Okay, so again, the steps of the scientific method are: you start with a question, you form a hypothesis, you create an experiment based on what you chose, you then collect the data during the experiment. Number 4, you analyze those results. So you compare all of the information that you gathered. And from all of that, then you form a conclusion about whatever the answer is for your hypothesis or the question that you originally asked. Now, during number 5, sometimes you find out that you were completely wrong. So at that point, when you form your conclusion, if you were wrong, say so. I'm never going to mark you guys wrong for admitting that you were wrong. Okay, admitting you were wrong is fine as long as you come up with ways that you're going to redo the experiment so that you can become closer to finding your answer. A lot of people are obsessed with the idea that science, you do an experiment in science and then all of a sudden you have the right answer. That is not true. Some scientists spend 10, 15 years trying to find the answer to just one simple question, or not so simple question. Okay, and they're just, they come up with a hypothesis, they run the experiment, they figure out they're wrong, they try another way, and over and over and over again. It can be really tedious, but again, it's about asking important questions and trying every possible way to get an outcome. And again, once they figure that out, or if they figure out, hey, it's impossible to find out why this is the way it is, they're going to communicate their findings so somebody else doesn't go and waste their time. So here's an example of how the scientific method could be laid out for a just normal day-to-day part of your life. So the question is, what is the fastest route to school? Okay, from my house. The hypothesis, we tend to like to write it in an if-then statement. I will go over that in another lesson. Right now, I just want you to read the idea, okay? So the hypothesis is, if I take Main Street to Elm Street, then I will avoid the light on Maple Avenue, which will mean Main Street is the fastest route to school. Okay, so what this person is saying is that there's a light on Maple Avenue that makes everybody late. How can I avoid that to make it the fastest route to school? Well, if I time it and I take a certain street, Main Street, then I will avoid that light. Therefore, it will be faster. Okay, so that's my idea. I don't know if it's true yet. That's why I'm going to experiment with it. So what am I going to do? I'm going to drive to school at the same time each day and at the same speed, taking a variety of routes. That's going to mean that this is going to take me a couple days to do. I can't do this in one day unless I take the whole day to do it. I'm going to make sure to include the hypothesis route, and I'm going to record the time for each route, okay? It's important that I go at the same time every day, because if I go at 8 a.m., there's going to be a lot more traffic than at maybe 10:30 or 12 when everybody's still at work, okay? So I need to go at a time that makes sense for me actually going to school, number one. And two, I need to make sure I'm going at the same time every time, because I don't want there to be a difference in traffic. And I need to be going the same speed, okay? If I take Main Street to Elm Street and I'm going 55 miles an hour, as opposed to hitting the light on Maple Avenue and going 65 miles an hour, the times might change. So I need to be going at the same speed, leaving at the same time, taking all different types of routes, and timing myself each time I go. That way my experiment is valid. Otherwise, some other scientist could come by and say, hey, you did this experiment wrong. You need to make sure all of the different factors are constant. Then I'm going to analyze the different routes, and I'm going to select the fastest, again, based on the recorded times that I took. Again, conclusion, I'm going to determine whether my route hypothesis was correct. Even if I found out that a different path is faster, I'm going to say whether or not what I thought was correct was or was not correct. So this is some vocab for you here. Independent, dependent, and constant variables. So independent variables. This is something that is changed in an experiment. So for example, in the last slide, right, we could change the routes that we take, okay? So I could take Elm Street, I could take Maple Street, I could take, whatever other street there is. The dependent variable is something that is measured in an experiment. So in our last example, we recorded the times. So recording the time is my dependent variable. And then a constant is something that is kept the same. So we kept the time that I went on the route and the speed of the car the same. Those are my constants. We have some examples that we'll do in class. We don't need to do those now. Again, I'm just showing you how I would label this experiment based on the vocabulary I just gave you. So my constant variables in the experiment, again, are the time that I'm leaving and how fast the car is going. My independent variable is what can change, what I have power over changing, which is which street that I take. And the dependent variable is what I am measuring. So how long each route takes. That is the dependent variable. So going back to our homework over here. So the second part of the homework is going to be about reading some situations, identifying control groups, independent variables, dependent variables, and what conclusions can be made based on data. Okay, very simple. I'm not going to go over the questions for this one. I can guarantee you questions from both the top of this worksheet and the bottom of this worksheet will be used on a test. So taking this homework seriously is important. Please let me know if you have any questions, and I hope that this was helpful. Thanks so much, guys. Bye.